Hi, my name is Kamila Hankiewicz, and welcome to episode 3 of Humans of AI interviews, where together with my guests from academia and business, we try to demystify what AI is and what it's not, and make it a bit more approachable and digestible. So today we are welcoming my guest, Dr. Janet Bastiman, Chief Science Officer, and AI Venture partner. Hi, Janet. It would be amazing if you could explain to our viewers your background and how did it happen that you got so much interested in artificial intelligence?
Okay, I mean, one of the things I always like to say is that I started coding last century. It's one of those great things we can say now that we're in the 21st century. So back in the 1980s, I got my first computer. I was very lucky. I think I was 7, 8 years old, and with my father being a teacher, we had access to all these wonderful computers that were coming out, and I just absolutely fell in love with programming. I'd always really been interested in mathematics, and I went through school, all the sciences, and I just didn't know what to do for a degree. And at the time, it was coming up for the Y2K, and everyone was doing computing and mathematics, and I wanted to be different. So I decided to do molecular and cellular biochemistry and learn about how we worked, which was absolutely fascinating. I spent 4 years doing an undergraduate and master's understanding immunology and the deep cellular mechanics. And then when it came to do my PhD, I was really focused on how that worked in the brain, because that was something we didn't really understand. I mean, we can see how cells work chemically, but how does that all fit together for learning? And that's kind of what I did my PhD in, was trying to get models from real physical neurons in the computer at the chemical level. So understanding the synapses and all of the neurotransmitters and everything like that on a very, very simple system, and how that could learn and adapt to its environment. Absolutely fascinating. But at the time, computing power, gosh, even 20 years ago, is just not what we've got today. And there weren't that many opportunities for someone that had done a computational model at the time to go into further study. So I went out into industry and worked my way up from a junior software developer and tester all the way through to CTO. And then about 6 years ago, when AI became a thing again in industry, I was in the perfect position to start building teams and start doing things from scratch. And that's taken me to where I am today, where I work with both small and large businesses in order to get their AI capacity up and running, developing brand new products, but then also working with companies like MMC Ventures, where I can advise early stage startups and also do those due diligences, so that we don't end up investing in businesses that are trying to pull the wool over our eyes.
AI hype.
Yeah, very much so.
Amazing. So I would love to understand a bit more on the PhD you've done. So as you said, you've done the PhD in biological accurate neural networks using machine learning techniques. And so could you explain the key insights on how such systems learn and how you see the artificial intelligence, the early artificial neural networks where took inspiration, like people took inspiration from that, right? How does it connect?
Okay, well, even really simple biological networks are hugely complicated. So I was working on a very small circuit from the pond snail, Limnaeus tegnalis, which has a repetitive action when it's feeding. So it rasps its tongue over lettuce or over whatever it's eating. And it's been known for a while that there are sort of 6 main neurons that are involved in this that have a repetitive pattern, and then about 40 other neurons that are involved in that. And they've been studied pretty well. So the first part was to create a model that just replicated what we saw. And we could do that fairly straightforwardly just by modeling very simple integrate and fine neurons and using very early machine learning in order to get them to give the right output. But what fell apart was when we were trying to replicate in the computer some of the things that we saw in the snail itself. So, for example, you can train a snail to think that different things are food by pairing them together, and then it will have the feeding mechanism even on things that aren't food. And you can see changes in the neurons, but we needed to adapt the model so that when given the same sensory inputs artificially, it would change and adapt in the same way as the real animal. And that was really hard because we thought we knew all the connections, we thought we knew all the biochemistry, but we really didn't. So part of the work that I was doing was trying to say, well, here are things that could be going on, so that we could then try and test that, with the whole purpose being that if we could get a good enough model of living neurons in the computer, then there'd be no need for in vivo research going forward, which was a huge goal. But there just wasn't the biochemical depth. We got to a point where I could demonstrate the learning in certain neurons, but not everything, because there are so many connections. And the difficulty is, as soon as you look at a neuron in vitro, sort of in a petri dish, it's lost all of that connectivity and even the 3D depth. So it's a really difficult problem. And even systems that are even better understood, so the worm C. elegans, every single neuron in that has been mapped. And you'd think that, you know, every neuron, every connection, it would be really easy to study, but there are people who've spent 8 years just looking at one single neuron and just trying to work out how that works. So we have all of this complexity and we're barely scratching the surface of it biologically, but we do have simple models that can explain relatively simple functions, and that's where the initial AI neurons came about. So you have this integrate and fire model, where you take all of the inputs that are going into a neuron, so all of the synaptic inputs, and then based on some rules, you decide whether the neuron fires or not, which is a nice simple model. And the very early convolutional neural networks, as I'm sure you and many of your watchers will have seen, you've got that model of the circle that's got multiple lines coming in and maybe multiple lines going out, and that's what that is. And for the majority of the purposes of AI, that's good enough. So all of this extra complexity that's in the brain and biological neurons is probably needed for other things. Evolution doesn't put things there that are unnecessary. So it's doing something, and it's definitely helping us learn, but we can see just by adjusting the synaptic weights that we can get learning in basic networks. So we have a very simple model, but you know, all models are wrong because they're models, but it's just how wrong do they have to be before they stop being useful? And what we've got right now is useful. So, but that said, I know DeepMind have been doing some wonderful research with reinforcement learning. It was last year, where they came up with hypotheses of how learning worked in the prefrontal cortex, and those hypotheses were then tested and found to be correct. So both sides are influencing each other, which I really love.
Amazing. It sounds very, very complex to me, but I would love to get some like materials if you have any. Apart from, I know that DeepMind is publishing lots of great resources, like on their LinkedIn as well. But if you have any other, like, let me know, or we can share it as well on like in the...
Yeah, I can send some things over. I've got some great diagrams just showing some of this stuff that I usually use when I'm doing talks, just on this is the simplification, but this is how complex neurons really are, and this is a simple organism, and I've got the map of the worm brain. And then if you extrapolate that to how complex we are as individuals and think, oh, how can we even come close to understanding how we learn at a chemical level? It's really difficult, but absolutely fascinating.
I guess so. I'm not even trying, because I will get lost. Amazing. So I know that you are also interested in problem focus. I don't really know what do you mean by that. So it will be amazing to understand that. And also the agile AI. Is it? Sorry for stupid question, but is it in any way related to the methodology like people are using as, like, you know, Scrum and Agile, or because I don't know anything about it.
Okay, the quick answer is yes, it's very related. So, firstly, the problem space. AI has been overhyped. You alluded to it a little bit ago, and it has been used, particularly in industry, as a bit of a sledgehammer to crack a nut, in that every problem needs to be solved with AI.
Yeah.
And that's not necessarily true. A lot of business problems can be solved more effectively and simpler using different methods, particularly when you're lacking in data, or even if you don't have the right people to try and build it.
Mm-hmm.
So it's not a fix-all project. It's not the magic fairy dust that will just solve your business problems. So having someone in the business or someone who can advise your business on what is the right thing to use AI for, are you as a business ready to even adapt it and adopt it is something that's quite critical.
Mm-hmm.
If you are in the right space, then furthermore, understanding what the AI needs to do is critical. Because again, you can't just say, make AI make this work. You need to have a particular problem, and you need to be very clear on what you want the system to do. Because whatever you ask your engineers, your AI researchers to put together, they will put together.
Mm-hmm.
But it might not actually solve the problem that your business needs. It might not add any value to your users. And before you know it, you can spend a lot of money on a team and all of the resources and prepping for no net gain for your business. And it's one of the things I'm quite passionate about, because AI resources take up a lot of energy. So if you're going to do something, do it for the right reasons and do it well, rather than just do stuff for the sake of it.
Yeah.
Which then leads me on to the Agile thing. So as a developer and development manager and CTO, having fast feedback using traditional methods was just not possible. So I was quite an early adopter of Agile, so that we could say, this is what we're doing. Is this what you expect? And getting that feedback. And once everyone in the business is on board with that, you can create better products faster. It can be quite painful for a lot of organizations, and I know a lot of companies aren't doing it right and end up with some sort of horrible hybrid of waterfall and agile, and it doesn't work in either camp.
Yeah.
But the same is true for AI research. So you don't want to be in a situation where you give a team a problem and then 6 months later they come back with something that's not quite right. By the same token, as a researcher with that hat on, you think, well, what can I actually show on a weekly, 2-weekly basis? And it can be quite difficult. So breaking the problem down into little steps is difficult for a lot of teams. And one of the things that I do is I talk to teams about how to break down the problem into steps so they can show value, they can get that feedback, and are we on the right track? Are we blocked? Do we need the data? And start thinking in that agile way. And that can really help with the interface with the rest of the company. So I've seen a lot of businesses where the AI or data science team is kept separate from the developers. They don't necessarily talk to the front end or the back end teams or the database people. And then when they do, it can be quite tense. So having a way in which all of these teams can get together, explain what they're doing, have feedback between each team so that they know when there's a blocker and when there's going to be help, can make the teams far more effective. And that you add in some of the extra elements of Agile in terms of that communication level, and then you start to add in some of the explainability of what you're doing, because people get challenged. And if you're not challenging, you're not doing Agile properly, because it basically means you're talking and no one else is listening.
The right thing.
So you get that improvement in the projects, ensuring that you've got the planning, you've got the estimating, you really know what you're doing. And before you've even started coding, someone else will go, hang on a minute, why are you using that data? Or don't we need this? Or you can't start because of that. Or actually, my model doesn't fit with what you're trying to build on the front end. And you can have those conversations week 1 rather than month 10, which is really critical. And that's one of the things that I try and do in all the businesses that I work with.
That's amazing. Because I obviously before having talking to you, I researched a bit, and there are not so many resources on that. Is it like only recently where people started like connecting the agile with that it can be also applied to AI, or is it your idea? Because it's very
I wouldn't like to say it's my idea. I think there's been a lot of it around for probably the past couple of years, and I think it's come out independently. So people like me that have got maybe backgrounds in multiple areas and have seen it work are applying these ideas in our own businesses in order to make it work. And I've been to a lot of conferences where there's been sort of AI ops and ML ops and all this sort of thing, but there's a lot of reticence, I think, from the teams themselves and also from the companies, because they've got a setup that works. Why change it? And if it's not implemented in the right way, it can be very, very painful for the teams and they'll reject it. And that's just the same as if you've got a team that's been doing waterfall methodologies for a long time and you just go in and say, we're working like this. It's a rare team that will just go, okay, yeah, that's what we're doing. Most of the time people are reticent to come out of their comfort zone. And this is how I work. I like having a very detailed brief and I like being left alone, and then I'll come back to you when it's finished. And if you try and take that comfort away from them, they can get quite defensive. So introducing it in the right way is really important. And the journey that you take the team on really depends on the team you've got and understanding the personalities you've got and what motivates them. And that's not something that can be easily condensed into a few slides or even a book. So I think that's why there's not that much resource around on it.
Yeah, amazing. It makes sense. And another area, I'm not sure if it's related or not, but another area you told me it's of great interest to you is explainable AI. Is it? Where does it fit?
Well, yeah, if you're doing the agile stuff, you can build the explainability in from the beginning, and that's one of the things that I've always been quite passionate about, but it's now becoming a main requirement for people building AI. And I'd say to anybody watching, if you're not adding explainability into your models now, start doing it. So it's all about ensuring that you can be very clear on how the inputs into your AI lead to your outputs. That's the high level. So regardless of what you're putting in, you need to be able to say very clearly to someone who is not an expert how you get the results you do. So if I were to ask you, how did you choose what you had for lunch today? You could give me verbal, logical reasoning, depending on what you're in the mood for, what you'd had yesterday, what you had in the kitchen, and then come to a conclusion. For a lot of AI, it's just, this is the answer. It's a black box, and that's not good enough. We need to be able to strip it back, but we're not interested in, here's the output of all the weights of all the matrices that make up the model, because that means nothing to anybody. What you do want to be able to say is, given this input, these are the parts of the input that cause this output. So for an image or a video, heat maps showing, okay, well, this is the region of the image that led me to conclude it was an outdoor image. Here is a bounding box of the face. Here is me tracking a car across the screen. Those are all very, very simple things, so you can see what's going on. And we've seen some of that output from some of the models. Similarly, when you're looking at predictability, so sort of rise and fall of prices or things like that, you need to show your error bars and how things are changing and how changes in the model can impact it. So usually these models predict on sort of past data that you fed in, feed in some different data, demonstrate how it changes on different things, and then fix it if it goes off the rails. And even if you're just looking at predictability based on raw incomes, so I don't know, like dates of purchase and amounts of purchase or videos people have watched, you should be able to show that changing certain parameters and putting different emphasis will lead to different results. And then you can clearly correlate your output with your input. There are lots and lots of different ways of doing this, and it's starting to be built into some of the libraries. There's definitely packages out there to help with that, but there's a lot of very simple stuff that should be included in basic testing of models or the documentation that's released with it, so that people understand how often things go right and when it goes wrong, what happens. And the reason this is critical is we're getting a lot of legislation come through, particularly in the past few years from the EU, about the right to explainability. So if you're building an AI that's affecting someone's life or their livelihood or something serious, whether they get a mortgage or a job, or whether they get released from jail, something critical, whether they need an operation, as an individual, you have the right to say, actually, why? Just as if you'd be able to get a second opinion from someone else. So if you are creating software, you need to be able to give them that answer, and give them that answer in a way that they can clearly understand. And if you're not doing that, you're not doing explainable AI properly. And the other thing about good explainability is if you get it right and you get your testing right, then you can avoid things like bias in your model.
Exactly.
Because it's easy for people to see what's going on. If you're just outputting numbers, it's very easy to hide problems with your model and think that you're doing things right because you're 99% accurate and everyone goes, great, yay, ship it.
Doesn't mean.
But you're not seeing that 1%. And what is that 1%?
Yeah.
So,
yeah, you are completely right. And like you said, it's for now, so many cases, it's just a black box. And there are so many cases of the bias in AI, such as the Amazon algorithm, which was rejecting automatically female CVs and putting forward the male ones based on the past data. So understanding what's going on and how it arrives to the result is really, really critical. But then, like, bias in AI means different things to different people, right? So,
yes.
So what does it really mean, or like what does it mean to you?
It's there are a lot of words in AI where the same thing will mean very different things depending on who you're talking to. I mean, even AI itself. I mean,
to some people, it's RPA, it's AI already.
Well, this is it. I mean, you ask, depending on who you ask and what their background is, AI can mean anything from the initial definition in the 50s of a system that appears to be intelligent, but could just be if this, then that, all the way through to the full-on human-like intelligence and anything in between. And you'll get people arguing vehemently that one thing is and one thing isn't AI. So one of the things that I always do when I'm talking is like, this is what I mean by AI, just so that we've got some common ground. And bias is another one of those words. So if you ask someone developing an AI system about bias, they generally mean about underfitting, overfitting, those sorts of parameters. So the bias in the model to be away from where it should be. So you want the model to be accurate, the model's consistently coming over here. That's its bias. However, it can mean a lot of things outside that. So you then take a step back and go, well, what about bias in data? So if you've done selective sampling of your data, or, I mean, there's a whole load of sampling errors, and I won't just reel them off because it's very clear on the Wikipedia page, you can have a look, but all of these sampling errors will lead to bias. And if you're making that mistake up front, it doesn't matter how good your model is, your model itself may be unbiased from an AI point of view, but if your input data is biased, your whole system will be. Exactly. So, I mean, some of the big fails there, particularly in retail, if you're only looking at your existing customers, you won't learn anything about your non-customers in order to get new ones. So you've already got that selection bias. And similarly, as with the example you gave with Amazon, if you're looking at an existing situation where you've got a heavily male-dominated environment and engineers and their CVs, you will build in that bias, no matter how good your intent. And then you can take a step back from that further and go, okay, well, I've dealt with my sampling errors, we've got this broad range, but if you then add human bias on top of that, because we are all biased, and it doesn't matter how good you think you are, every single person is biased. And there's this wonderful study, I think that's about 180 biases that everyone has. And there's this wonderful graphic that I will pass you to LinkedIn. It's on designhacks.co, and I use this quite regularly.
Maybe you can share it right now.
I can share it right now. Let me see if I can do that. Let me go share screen.
I think I know which one you are thinking about. Let me show you.
Yeah, I think you need to give me permission to share my screen.
Okay. Multiple participants. No. What does it do? Does it say anything? I don't. Yeah.
Yeah. No, it's coming up now. So let me share this. So.
No, I didn't see that.
Yeah, so this is the cognitive bias codex. So these are all the human biases, and they generally drop down into the fact that we're either overloaded with information, we don't have enough information to get meaning, we need to act fast, or we don't remember things. And definitely we should all be aware of this first circle. So we notice things changing.
Yeah.
But if we're missing information, we fill in information based from our own experience and our own knowledge.
Yeah.
And we use our own experience and knowledge in order to predict what we think other people will do. And we get surprised when other people who don't have the same experience as us think differently. So if we're aware about all of these biases and how they can affect us thinking, it helps us to understand the information that we've got. It helps us to think critically about what we've got. Because the biggest problem is that if we are presented with information that reinforces our viewpoint, we believe it. If we are presented with information that challenges us, we challenge that information far more rigorously. And this is why we end up with bias bubbles on the internet.
Yeah, social media, yeah.
Yeah, so I mean, I've got, fortunately it's not behind me, but I have the big A0 poster of this on the office in London, and it's just there as a constant reminder for me and my team that we need to be thinking about this, because if we don't, we can end up making a whole host of fallacies when we build things. I can give you the link for that.
Yeah, that'd be amazing. I saw one which had like a examples, like images per each, but it wasn't 180. That's amazing.
Yeah, I mean this was put together. I'm always very clear when I show this in lectures.
Yeah.
I use a slightly smaller version that's got the URL of it on the background, because it's really important that these guys get credit for this.
Oh yeah.
Work went into it. And it's always when people put their cameras up to take photos of it, it's like, please go and give these people money and get a picture of it yourself from them rather than just.
Yeah, you're right. Okay, so that was an example you gave with we gave the example of Amazon, and we gave the example of
retail. We talked about Amazon.
Yes, exactly.
I mean, there's loads of others, and it's one of those things. I mean, there's some of the horrendous examples of. I mean, it's not AI, but hand dryers only responding to wet skin. It's that sort of thing. But even the AI gender recognition systems, they are 99 point something accurate on white men. You go to white women, they drop down a little bit. You go to non-white men, they drop down further. You go to non-white women, they're right down. And it's because these systems have been built, and the data sets that they've been built from are generally not that diverse. And when you're in a team researching and you've got something to test, you grab some test data. And what test data do you grab? You grab the pictures of all the people that are around you. You put them through, that works, great, done, ship it. And that's the problem. If you don't have that diversity in the teams, you don't have that challenge, these things can slip through the cracks. And then furthermore, you end up with systemic problems. So one of the things I gave evidence on a couple of years ago to New Zealand AI ethics and law investigation was the Compass system, which I think you've probably heard of, and I'm sure most of your audience have, that this was on paper a great idea. let's build an AI system that can remove human bias from a system that's inherently racist. And rather than getting someone to go up in front of a human, let's let an AI determine whether they're likely to reoffend, which sounds great. Get rid of human bias.
Yeah.
However, if you then build something where the data that's been used and sourced is based on extreme amounts of systemic racism and all of those horrible things that we know happen in the industry, that it doesn't matter how good you build the model, you will end up with a horrendous model.
Mm-hmm.
They then further exacerbated that by going, the best thing we can do with this model is minimize our false negatives. It's safer for people if we don't release potential criminals. So the problem with AI is that if you have an unbalanced data set, you cannot minimize false positives and false negatives at the same time. You drop one, you raise the other.
Mm-hmm.
So they had to choose, and they chose to get rid of the false negatives. So better to keep people imprisoned than release potential criminals, which again, on paper, sounds like a good idea. But you feed in this horrendously biased data, and even when you take out variables that you think correlate with race, there are so many other variables included, particularly the socio-economic status of non-white individuals in that study. And you end up with correlations with race that are not intended, and you end up with a system, the algorithm, which completely exacerbates the racism of the system, which is why it was pulled. But that sort of thing should not have got to that point.
Mm-hmm.
The problem that I see is a lot of early AI research was focused on let's maximize the accuracy. And some of the people that I worked with in the early years of this were make your training data match the inputs you expect, and then you'll get high accuracy. Now, if we look at something that's going on right now with COVID,
Mm-hmm.
If I said, okay, well, let's make something that determines whether you got it or not, and if you got it, you stay home.
Yeah.
Why not make something that's 100% says, yes, you've got the virus, stay home, because then you'll catch 100% of the cases, and who cares about the false positives? And this sort of thing is a huge problem, because if you're looking at something that's a speck, you know, that happens maybe one time in 1,000, you need to look at the impact of getting that small thing wrong,
Mm-hmm.
rather than getting the big thing wrong.
Mm-hmm.
So if you're looking at medical diagnosis, for example, you'd rather have some false positives and say you need to come in for a second test than miss that one person.
Mm-hmm.
And this is something we really need to consider, not the raw numbers of accuracy and precision and recall, but the impact on the individual or the company or whatever else of the AI, and judge the AI on the impact, not on the numbers. Because I would rather have something that was slightly lower in its precision, but the impact was better and how the outcome was used was better.
Mm-hmm.
Because then you need to consider, well, is it going to be used directly? Is there going to be a human in the loop? And all of these things. And if you know that there's going to be a second level and a human in the loop, then you make a different system than if you know, no, this is going to happen autonomously.
Mm-hmm.
And that's some of the problems that we've got right now with autonomous vehicles.
Yes.
Is what authority do we give them? What decision do we give them to ensure safety, and whose safety is prioritized? And then we get into the trolley problem, and how people answer that problem depends on their personal biases. So it's a huge minefield of things to consider.
Yeah, it's very complex. So where do you think the AI is going? Like which like recent developments are increasingly like interesting and we should like more focus on?
Well, I mean, there's been a lot going on. I mean, interestingly, in the past week, we've seen a lot of companies change their direction. So, for example, facial recognition systems are being paused worldwide, mainly because the general public are getting more engaged and understanding, which is a great thing. We need people to be involved in this.
Yeah.
We need people to understand what's going on. There's some great research going on in conceptual understanding of, for example, text and imagery, and really trying to get systems to understand's a big word, but get a good perception of what's in some data.
Mm-hmm.
And it's really pushing the boundaries of what we think computers can do and what we think these networks can do.
Yes.
And particularly in terms of mathematics and neuroscience, which goes back to what I was talking about at the beginning, just in terms of computer science, in terms of AI, is helping us understand sort of biological neuroscience and vice versa, which is great. One of the reasons it's grown so fast is, unlike a lot of other fields, this has been practically 100% open source from the beginning. So all of the research has been available. It's all pretty much in Python, which is very easy to pick up as a language. People can just download the repos and adjust things, and everyone's just building so quickly.
Mm-hmm.
I mean, if you look at some of the general adversarial networks, 5 years ago, it was a grainy 16 by 16 image that if you kind of squinted at it, looked like a face. These days, you can go to thispersondoesnotexist.com and you will get a full HD image that's generated.
Yeah.
And it's amazing. I mean, that's 5 years. So,
but that's also the part of like cloud computing becoming so available, right? And the processing power, it's much more.
Yes. So it's processing power, it's understanding. I think it's more the understanding and the speed in which we can see other people's work and build on it than the processing power itself. Because while GPUs have improved significantly, the speed at which things can be generated, yes, it has improved. But you could put multiple GPUs together and do things quite a few years ago. I mean, going back to my PhD, which I think I could probably redo in about a month of using our equipment, but I had to daisy chain lots of CPUs together and sort of Beowulf system in order to get the processing I needed, and I would have killed for GPU access in those days. But I'd also killed for Google and the ability to look up things on Stack Overflow rather than having to work them out for myself. But that's a different matter. But so because of all this democratization, everything's moving at such a pace, so it's really difficult to anticipate where the next big thing is going to be coming from. The problem with that is that as researchers, we are creating things because they can be created, and it's, oh, here's the next increment, let's do this, and we're putting the papers out. Because we're moving so fast, one of the things we need to do is consciously take a step back and think about how things could be used. Because there are plenty of people out there who can take this research and do things that we don't intend with it. Mm-hmm. And sometimes that's the development of something funny. It's, like the face swapping apps and things like that. Lots of fun, everyone loves them, everyone uses them. And on the other side, you've got some more nefarious use of exactly the same technology. So deepfakes last year went from not being a thing to being one of the most common words. And it's that's something that we need to be concerned about and worry about, because as we're releasing more and more of this technology and it's freely available, we need to start thinking as researchers of different ways that this could be abused rather than just used.
Mm-hmm. Mm-hmm. Yeah, you're completely right, and it's not only deepfakes; it's also robotics, right? Like there are so many double-sworded use, let's say. So let's talk more about deepfakes, because it's a very interesting subject, and I've researched that in few years ago, London-based AI firm, very well known, but we are not advertising, found 15,000 deepfake videos online in September. Oh yeah, it was, last year, in September 19. And near doubling over 9 months. And 96% of it were pornographic. And 99 of those mapped faces from female celebrities onto the porn stars. So as new techniques allow unskilled people to easily do such things, what should we do about it, and how can we make sure that we as individuals are protected as well?
That's a difficult question. So let's start with what they are first. So I spoke about the general adversarial networks, GANs, that can create faces from nothing. So this is an extension of that technology. So we started off with, let's swap a static face into another face, and then, okay, we can do this in video, and okay, let's put Nicolas Cage on Everybody and Friends, or let's put him yeah, let's put him as the face on Indiana Jones. And we all laughed, and it's like, great.
Yeah.
And then, as you said, there's these people that thought, if I can put Nick Cage's face on this face, then I can put this celebrity's face on this face, and I'll upload that and get some notoriety. And that's exactly what happened. Mm-hmm. And people ended up making some absolutely terrible ones, which they uploaded for just humour reasons. And then people were actually uploading some quite convincing ones.
Yeah.
And it's really difficult sometimes to spot them. So the early ones, you could tell because the faces were quite mannequin-like almost. They weren't very expressive, they didn't blink. Yeah. So the early detectors were, let's do the blink test. So they'd see if the model blinked. It's like, aha, that's not real. But the whole point of GANs is that they learn to fool a detector. So as soon as you introduce a detector, they can take that as an input to go, okay, I need to do better. So you then started automatically improving them. Mm. So then you ended up with ones that didn't, that did blink, so they couldn't be detected by that. So then started looking at the edge detection. So if you've inserted a face into a video, there's kind of aberrations which might not be visible to the human eye, but a computer can pick up on, and it'll go, aha, I think this is fake. Which again is fine, but then as you start moving that out from just sort of this part of the face to the whole head, and we've seen you can generate lots of things, that becomes harder and harder to detect, because most photos that are online and most videos have been edited to some extent, whether that's just Photoshop touch up my appearance, or a little bit of smoothing, or changing backgrounds, tidying things up. So there are those aberrations there already, which makes it really difficult to spot. So we have to start thinking about other things. Now, so far, there are no good solutions for this. I've seen a lot of things suggested. So, for example, blockchain, which is the current hype thing and is the solution to everything, could potentially be used. If you have a record of valid images and how they've been changed, then you can verify. That is only being suggested for celebrities. Mm-hmm. So that wouldn't affect the likes of you and me. So that wouldn't mean that we could protect ourselves, which is a huge problem. That might work. It really depends on whether people find a way around this. But again, everyone would need to sign up for it. It's probably going to be years before people come up with a standard. Mm-hmm. There's also some suggestions of adding noise to images and videos. So you might have seen the wear this t-shirt and you become invisible to face detectors, yes. Things like that. There's noise that you can add onto images that changes how AI perceives them. So lots of papers on this. You add noise that a human eye can't see, and suddenly a picture of one celebrity is classified as something else. If that could be added automatically at the time that you take an image or you take a video, then it would be harder for someone to then take the face. Not impossible. They just have to do it the old-fashioned way, because faking has been around for a long time. It was just hard work. And if you wanted to take someone's face, yeah, I mean, movies have been doing it for years, but if you wanted to map someone's face onto someone else, you had to like digitally cut it out, map it, tweak it, and it required skill and time. Mm-hmm. The deepfake tech is a game changer because it requires neither skill nor time. And one of the lectures that I did, in fact, last September, when your firm did, the AI firm did that research, was I created my own deepfake of me on the International Space Station. Mm. And it was ridiculously easy. It took using a laptop that I used for gaming, so not top of the range at all. It had an NVIDIA 950 card in it, so a few generations old. It took me about half an hour to get the software off the internet, another half hour to grab some images of the astronaut that I wanted to swap into. So I had some training data. I spent 2 minutes recording a video of myself around the house, put it into the software. A day later, I had a 3-minute video of me on the space station. The hair was wrong, but you know,
Who cares?
it wasn't great quality, but it was good enough for like a Facebook video. So
That's
something
really
that would
cool
play
project.
small.
Well,
Yeah, it was a lot of fun.
how did you get inspired? Was it for your own like personal purposes, or?
Like most things I do, it's either someone says something and they don't have time to do it themselves, and I go, that's cool, I'll do that. Or someone says you can't do something, I go,
I will show you.
It's like, yeah,
Hold my beer.
I wrote a neural network in a very esoteric programming language, just for fun. But I mean, this was one of those extensions that it was like I was having a conversation about the space station, how great it would be to go up there, and then the conversation moved on to other things, and then deepfakes, and
Awesome.
someone said, "Oh, they're too difficult. No, no one can really make them." And it's like, challenge accepted. So how easy is it for somebody who knows what they're doing to create one, and therefore how easy would it be for someone who doesn't know what they're doing to create one?
Mm-hmm.
So the only thing I did was, in that lecture, I'm not going to show you how to make a good one, just how to make one. And one of the biggest things that I found is that wearing glasses really throws off a lot of the open source software because generally what it's trying to map is from your eyebrows down to your jawline.
Oh yeah.
And of course, I am incredibly short-sighted, so my face goes in on my glasses, not quite that much, but about that much. And of course, because of where my eyebrows are, I've got this dark line here as well. So when I did the deepfake, at times, Samantha Cristoforetti, who's the astronaut I was replacing, when she was doing sort of wide eyebrows, I ended up with like 3 eyebrows. It was quite interesting. So being a glasses wearer is quite a positive thing right now.
Amazing.
But yeah, it is really hard to spot them. So if you, the good ones that are out there, and there are plenty of good ones. There's a fantastic one of David Beckham speaking.
Synthetica. That's what. Yeah.
And that's one of the positive uses of it. I mean, you can imagine you've got so many children at the moment throughout the world stuck at home. You could have a teacher in one part of the world giving a lesson, and that lesson being near real time, converted into their local language automatically, and their lips being adjusted so it looks like they're speaking the local language, and they can have that experience rather than it just being subtitled or the time waiting for things to be dubbed. There's lots of other positive things. So one of my friends works with people who's got speech disorders. So if you could have a way of helping them communicate, particularly on video, where they can't necessarily speak correctly, that'd be fantastic. And then also, I mean, in addition to the movies, which we've seen it done lots, and that is getting better. And there's a whole legal issue over whether a dead actor is owned by the family or by the movie studios, because it's, I mean, that'll get worked out. It'll get put into their contracts, and it'll become a thing going forward, that if you agree to do a movie, you agree that your likeness can be used in perpetuity, I'm sure. But yeah, you've got all of that. But also, I mean, if we think about the grieving process, if you lose someone but you've not really got closure, being able to recreate that person and have that conversation with them and have that natural response could be very healing for a lot of people. As well as the educational of being able to animate the Mona Lisa or bring Einstein back to talk to the classrooms, and all of those sorts of things. I mean, there's a whole load of positives, but it is being abused. And not only with the pornographic stuff that you touched on, but with the elections last year. While I don't believe we had deepfakes that were used in seriousness, there was definitely deepfakes created that were designed to show how misinformation could be spread of Boris Johnson endorsing Corbyn and Corbyn endorsing Boris Johnson. And it was very convincing. And I think the key takeaway from that is that we need to really, really question what we can see. In the lecture on deepfakes, I say it's like, you have to question the evidence of your eyes and ears. It's a quote from 1984, but we have the potential to be fed things that are not true. And it would not take much for someone to take a grain of truth, so something believable you can hook onto, and create a deep fake that played on that truth that could then take you from position A of thought to position B and truly believe it. And that's what we need to be aware of. We need to be really, really strong on understanding our biases and thinking critically, because it used to be pictures or it didn't happen, and then pictures can be faked, but if you saw a video, it's pretty believable.
Yes.
And we're fed videos every day, from cats doing crazy things to all sorts of things happening on the news, and we believe it. We take it all on trust, depending on the source. But how sure are we that the sources have got things correct? If they've got an anonymous source that's given them a video of something happen,
right,
we will believe that if it reinforces what we already believe. If we see a video of some violence happening, it's like, I've seen other videos like that, so I will believe this one, even if that's not true.
Yeah.
And we need to be really, really careful about that. But it is mentally exhausting to strongly challenge every single bit of information you are presented with every day. But we're going to have to start being better as a society. Otherwise, we can easily be manipulated, because all of the technology is out there right now.
Yeah, you're right. It can easily become very polarized, what we have to believe. So, and we've already touched a little bit on the ethical part of AI, but maybe you can tell us a bit more on any institutions or any new legislations which are happening to do something about it, to make sure that we are creating ethical algorithms.
It's a really difficult one. A lot of the societies that support AI and data science are talking about this. So over the past month or so, as part of my work with the Royal Statistical Society, I've been involved in this huge cross-industry group with the BCS and the Alan Turing Institute and IBM and all big players, trying to come together for an understanding of what does AI and data science really look like for accreditation purposes. And one of the big parts of that is ethics, and making sure that if you are working in this industry, you need to understand the impact of what you are doing. We don't believe that the person building it themselves should necessarily have the final accountability, but they should be able to ask the questions and raise those concerns and questions, and they have a responsibility to do so. One of the things that we were discussing is almost like the doctor's Hippocratic Oath. Should we have the equivalent, so that there's that imperative on people to think about what they're doing rather than rushing to get the next application, the next paper. And we do need to take a step back and think about it, because once these things are released, they're out there. So it does not matter if a law comes out tomorrow to say deepfakes are banned, because people can and will make them. If you can do some things, I think I said earlier, it will be done. Someone will be doing it somewhere. And one of the big problems with sort of scientific knowledge is we want to share it. That's the whole purpose of science. We want to get that knowledge out there. But there comes a point when we need to think about what that knowledge means, and should we take that step, because you can't untake it once it's out there. And I get slightly frustrated when people like Andrew Ng come out and say that he worries about some of these problems, like he worries about overpopulation on Mars. Because if we wait until it's nearly a problem, until it's nearly out there, it's too late. We can have these discussions about the right ethical practices and get them in early. It won't be a problem, because if too much becomes out there, then someone will be able to connect the dots and build something bad anyway. So I'm very much in favour of ensuring that we have clarity on what the models are doing, where the data's come from and its provenance, so that we can go, actually, this is a problem. And it doesn't necessarily have to be made public. I know a lot of businesses will want to keep that knowledge, but as long as it's documented somewhere, so that if questions are raised, they can point at it and go, no, we did the right thing, then I think everyone will be happy. And it is becoming regulatory. So a lot of industry, so sort of medical, financial industry, where you have that material impact on people, it's a requirement, and that legislation is already there, that you need to have that explainability. So we add the ethical side to the explainability, and we'll be in a really good place going forward.
Amazing. So fingers crossed for that. So with all the bad and the good parts of AI and then deep fakes, which is increasingly important, what do you think the future will look like for us?
It's really hard, because one of those things is that we tend to overestimate where we'll go in the short term, but really underestimate in the long term. I made a comment, I think it was 2 years ago now, when my daughter was 6, that I didn't think she'd ever have to learn to drive, because I thought that autonomous vehicles will be around and there'd be no need for it. She's now 8, so 10 years away from driving lessons, which is kind of scary for me. But we're not close enough. We've not even started seeing those big scale trials, because it's so difficult for situations like, central London, where I work mainly. You've got so much going on there. You've got all the tourist pedestrians, you've got couriers, you've got cyclists, you've got buses. There's trying to drive that alongside all of the very confusing old city streets, and all compared to nice, clean test environments, is very hard. Motorway autonomous driving, I think, that's a much simpler problem, and I think we can get the vehicles that can do that. They already exist, so it's just making it legal for them to do it automatically. So I still think maybe 10 years, I think we'll start to see them. But I think it's going to be a few more years before people will stop having to learn to drive. So that's one thing. I also think we're going to see a lot more, it's called sort of augmented intelligence. It's another on the AI, is that just like calculators and computers freed us from having to do lots of manual tasks to being more creative in our roles, I think the same thing will be true. Even some of the systems I've put together, it's meant that rather than having to do the same thing over and over again, some of the marketing people and creative types can go, actually, I don't need to do this anymore. I can do this. This is the bit of the job that I love. I hated the 80% I spent doing that. So it's giving people changes in how they do things. And I think that's just going to gradually come in, because it's there, it's coming. People are building applications to make life easier. Even before AI, applications were coming to make life easier, and we're going to see more of that, I think.
And it will be much more personalized, right? Like whatever we want to pull in the right moment, we will be able to see.
Yes, but that involves us voluntarily giving up our data, which is really interesting, because I know there's a lot of people who, browsers all in private mode, they don't accept any cookies, they don't want anything. But by the same token, I quite like having the right film recommended to me by Netflix. I quite like having adverts for things that I'm actually interested in, and I make a concerted effort to click on things that I'm interested in, so that I know the underlying algorithms start giving me the right stuff, because I don't want the algorithms to give me stuff based on my age and gender, because then it gives me a whole load of things that I'm not interested in. I want to see the Raspberry Pi adverts and the new NVIDIA cards and the sci-fi stuff, And I also want to see some of the craft stuff as well. I want to see the Lego being advertised to me. But, unless
That's the Lego? You've made it from Lego?
Yes, it's the Lego ISS.
That's so bring it closer if you can move it.
Yeah, I can move it. Move it.
Oh wow, amazing.
There we go.
Wow.
It's pretty detailed. Just.
Where did you get the whole? Is it like? Oh wow.
It's an official advertising for Lego here. It's an official Lego set.
Oh wow,
Of
amazing.
the ISS, and it's got the shuttle that comes with it, and the only thing it's not got is the dragon to go with it, but it does have the docking ports. I think one of these is where the dragon docked. We were watching the launch and the docking, and I was using this to show my daughter and my husband where things were going. But
amazing.
Yeah.
Will the dragon?
So,
the dragon will be also released, or you have to like you need to build it.
That's a separate thing to build. It's been suggested because it's completely off topic, but Lego asked people to submit ideas, and if they get enough votes, they turn them into real sets. And the ISS was one of the sets that they released earlier this year because it got the most votes in 2019.
Amazing! That's so cool. Wow! Send the link. My boyfriend is also a huge fan.
I will do.
I know what I'm getting for birthday, but I'm sure he knows it already. Awesome. So before I forget, does your project with the deepfakes in the space, does it? Did you upload it anywhere?
Yes. So that I've done it a few times. I think the only one that's currently on YouTube is from the Tech Exeter talk in September last year, but I can give you a link to that as well.
Yeah, awesome.
And it goes through basically how to create one from scratch and all of the steps you need.
Wow.
And it is surprisingly easy.
Okay. And which are, like, do you have any other projects coming up in the same space?
I've been, just for my own amusement, I've been playing around with some of the voice synthesis.
Mm-hmm.
So as I think I mentioned, I have a friend who works with people who have speech issues. So I wanted to try and come up with something that if they had some good recordings of their natural voice, they could type something, and rather than the generic voices that you can get, it would give them their own voice back. So I've been doing that. And also, as I mentioned, I've been playing around with some esoteric programming languages. There's a thing called Rockstar, because a few years back, all of the job adverts said, I want a rockstar programmer, a rockstar designer. Yeah. And this really great guy called Dylan Beattie came up with the rockstar programming language so that you could say, I am genuinely a rockstar developer. So I decided, I set myself a challenge to be a rockstar neural network developer. So I took a very simple neural network in Python and converted it to the rockstar programming language, which is basically a language that's defined by sort of 80s, 90s rock lyrics. So your source code looks like a rock song from the 80s, mm-hmm. which is really weird. But because you have, it's very simple, so you don't have any libraries, and you don't even have basic mathematical functions. So trying to do, for example, e to the power x in Rockstar, I had to do a Taylor series expansion in all, basic first principle stuff. And I love that because it just helps you really underline what you're doing and make sure you're doing things properly and you really understand it. So yeah, I did that, and the source code for that's online as well. So
wow. Okay.
That's the sort of crazy stuff. When I'm not building Lego, that's the sort of stuff I do.
Yeah, I can already sense that. It's amazing. But you are also painting, because I see the figure behind.
Yes, so I do drawing. I don't have any in with me at the moment, so I've got my little figure there for drawing, and the microscope for homeschooling as well.
That's so cool. Awesome. So I'm sure there are so many other topics we can talk about, but I don't want to take more time of you, because we were supposed to do 1 hour. It was more than. So if you have any other materials or anything you want to share, then please do, and I will put it on the comment section after. And also, where can people find you?
I have a blog, janjanjan.uk, where I talk about some of the fun stuff I do, so my Lego builds,
Oh.
neural networks I've built. I also talk from a sort of a leadership point of view, so the sorts of things you need to do to get into AI and data science, how much maths do you need, and also because for the past 6-7 years I've been doing a maths degree on the side, because I self-taught maths, so I did maths to A-level, and then because my undergraduate was biochemistry, and then I went straight into my PhD, I learned the maths I needed as I went along, and I was very aware that there were gaps. And while everything I wanted to learn was online, if I hadn't had a formal course for an exam, I'd have never have made time for it. So I did a maths degree with the OU, and Wednesday I had my final exam, which was an interesting experience, doing an exam at home. But yeah, so I've been doing all of that. So that's something else that I blog about, is the different modules, how that compares to the traditional university experience, because I'm a huge believer in lifelong learning, and that you know, the person I was at 18 to 21 when I did my undergraduate degree is very different from the person I am now, and how we learn and how we approach learning changes. So even for people that maybe didn't feel that further learning was for them when they were a teenager, they can easily pick stuff up now and learn new things and get excited by new things.
I want to see the Lego. That's really, really cool. I hope like you're building with your kid as well, and showing.
Yeah, she's not allowed to touch this one, but she, most of the Lego is in her room, and she prefers that I build it, and then she'll take it apart and make it better. So that's fine.
Yeah, that is amazing. Like when I was a kid, it was only like Barbies, and it was
I had those as well. I think any form of imaginative play is fantastic as a kid. I think it's really important, just to do stuff, and even though she's got the screens and things, just being able to create and role play and come up with all these things is really important.
Do you see the difference of, I'm sure like you don't remember how you were learning, but do you see the difference in your daughter, how she learns by using the technology like smartphones and computer? Do you think they are faster, or it's like worse for them?
It's just different, I think, because so up to her age, I mean, I was just reading all the time. I didn't have a TV or anything in my room, but I was reading loads, and I was doing, I had Lego at that age. I had Cindy dolls, not Barbie for some reason, and flappers and all these sorts of things. But then I also, just because I was interested in it, I had a soldering iron and a chemistry set, and I was doing all these other things. And then we got the computer, and of course those early computers didn't come with monitors, so I had to timeshare that with the telly, which made for interesting experiences. And my dad was very much, if you want to play games, you've got to create them. So, which was fine. So my brother and I learned to code so we could create our own games. And yeah, I think had I had a computer in my room, I'd have been exactly, I mean, she doesn't have it. She has her own tablet, but not a computer. But I'd have been constantly on it, constantly doing stuff, learning stuff. I'd have been all over Wikipedia until 3-4 in the morning every night, because that's what I was doing with books. So it's just the nature of learning's changed. Exactly,
and letting people understand what's possible, right? Because, for example, yesterday, I'm so bad with closing the conversation. I'm taking your time, but yesterday I was on a workshop with EBRD, the European Bank, and we were talking. Some ladies were talking about what's been happening in rural places of like Africa, when like women got access to the computers and internet, and they were mainly using it for social media, because they didn't know that other things are possible with this. So you have to, like, you can have the access, but you have to know also, like, you have to understand what's possible, like what can be done with it. So, same with using computers. It's not only games, but games are obviously also very educational.
And remarkably so. I mean, there's problem solving. I mean, even from the 8-bit stuff that I used to play, you've got fine motor control on your fingers, you've got problem solving, you've got observation skills, sort of reflexes, all those sorts of things. And then even the modern stuff, you look at Roblox and Minecraft, they come with coding environments. So when you're of the right age, you can build your own levels and share them. And that's, you know, that's really cool, because it's getting kids engaged and teaching them these coding skills from an early age and how to think in the way that they need to structure a program. And then because they need to make it fun, it adds in reading, so they've got to understand what's going on, and writing, so they've got to put the text for their characters, and art components. So it's really bringing everything together. It's not just sitting writing text, you know, into a terminal. It's a real multifaceted educational environment. And you know, you've got lots of augmented reality games and things that can add to that as well. And I mean, saying, going back to the Lego, even the Lego, you've got sort of robotic controls, and toys are not just sort of dumb bits of plastic anymore. There's a lot more to them. And you know, I mean, I'd love to be grown up right now. So much fun.
And yeah, we are all kids. we have to. We love to play. Okay, I'm not taking more of your time. I know it's Friday, and then you want to relax and do the raspberry cookies, raspberry, cakes, or if you like raspberry.
Yeah.
Okay, I know. When we meet, I will find some good place for that, unless you know some. And I will be sharing this on this Monday. So by then, if you can share the resources, that will be amazing.
I will get on that now before I forget.
Amazing. Cool. So thanks so much, and have a lovely weekend.
You too. Thank you.
Thanks, Ruby. Bye.
Bye.
Where do I record? Okay, stop.